Great. So today, Tim will talk to, why circularity. It's obviously a hot topic, but also, what the actual importance of circular economy and its relation to LCA. Then we'll look at recycling in LCA and the different allocation methods. Then we're looking at measuring circularity and linking it to LCA. So how LCA and PIQET resolves double counting, looking at the different circularity results in PIQET. And then we're going to delve into a case study using PIQET, looking at house cleaning bottle product alternatives. So yeah, I'll let Tim kick off.
Thanks, Kate. And so we get asked a lot of questions about the circularity metrics in PIQET and why aren't they showing certain results and what people understand about circularities. We really wanted to talk through those and talk about how they interact with the recycling and reuse measurements and what the pluses and minuses are using both of those within the tool. Before we jump into that, what's interesting about the circular economy, I suppose, from a packaging and from a life cycle assessment perspective. I think the circular economy model as a conceptual model helps with thinking through material loops and materials in the economy and how important it is to try and close those material loops over time. And this is really the sort of, the logical next step, having solved in large part the issue around fossil-based energy driving the economy. Once you solve that, what you're left with then is really material extraction and the processes of material upgrading as one of the major impacts of the economy. And so materials is like the second major cab off the rank after dealing with the energy debate. The other thing which is really enabling about as we increase the level of renewables in various economies is that things that were previously not environmentally possible with circularity become possible, because circularity typically has a lot of reprocessing, typically a lot of mechanical energy and activities, all of which required electricity. And while electricity, particularly in the Australian context, had a very high footprint, you didn't need to use much of it before you'd actually produced a material with a higher footprint than virgin materials. Now that that electricity has come down, the ability to make secondary materials and to have complex logistical processes, we will see that that the benefits of secondary materials will actually increase over time compared to their virgin counterparts, which usually don't have the same levels of benefit from renewable electricity, putting aside maybe something like aluminium. So this is part of a just a broader strategy within the circular economy. Now, in the packaging sector, we talk a lot about recycling and recycled content. Just to remind ourselves that within the circular economy, we are first.
Shall we take? Sure. This one? This one?
Okay, we could just mute the microphone, that'd be great. So within the broader circular economy, what we're really interested in is sharing things, making things last longer, getting more out of what we do before we start to look at the options of recycling and recovering materials. But nevertheless, within the packaging area, some of those are a little tricky to implement, but we shouldn't forget those activities, that other activities of maintenance and redesigning systems to actually reduce the overall material demand before we just look to things like recycling. I suppose the other thing about the circular economy, love it or hate it, it really does speak to business. It's got the word economy. It has a much more business sense about it, and gets a lot further than things like industrial ecology or industrial symbiosis, which were very academic in their day and described many similar concepts, but didn't really put them in a business context and didn't get the traction that we really now see circular economy getting with the introduction of the new standards, and it sort of reaching the boardrooms and planning and design areas of companies. Okay. Recycling, obviously highly relevant to the packaging sector, and as I mentioned, it's like the fourth best option within the circular economy, not our first go-to. Now, the interesting thing about recycling is it happens at both the beginning and the end of product lives and packaging lives, and that creates a challenge for us from an accounting point of view within the LCA framework, and that challenge has been something that no matter how many times we go over it, we look at it, it's still a bit of a mind bender to get people's head around. So I think it's worth going through what that challenge is, and how we need to what the solutions we are that have to develop to assess that within the circular economy and the LCA context. Okay, so recycling and LCA. We need to be able to resolve double counting when testing alternative results. The issue we have, if we lay out a product that maybe something is made of low density polyethylene, it's sent to recycling, there is some recycling, produces recycled product from a process that does LDPE recycling, and we get a recycled product in the market. That recycled product then is sent out, used and sent to recycling again, maybe a little bit goes to landfill, and the cycle starts again. So we have this send to recycling down here, and off it goes. Now, we will often, if you are a person or an organisation that is undertaking this recycling, you will often think about the process when you send things to be recycled, that the benefit of that is that you're displacing new materials, new virgin materials. And so there's this conceptual idea that that the activity, at least at this end point of the life cycle, has the potential to displace virgin materials, which is great and which is true. Now, when we go to put a boundary around this in life cycle assessment, typically people put a boundary around the whole process, what we physically see. And we physically see that we have some LDPE recycling, we produce recycled content, we send materials to recycling, and then we go and we produce material that can go back into the economy. Unfortunately, this boundary is double counting. We count at the beginning of life, we count that material is recycled, and at the end of life, we count that it gets recycled and displaces virgin materials in the economy. That effectively counts the benefit of the recycling twice. It counts it at the input side and counts it at the output side. The problem is that when you count a credit at the output side, you essentially you can only take it once, and so you've either got to count it at the beginning or at the end, or some blend of those. So what we have typically done, there are two solutions to this dilemma. One is what is referred to as the cutoff solution, very, very popular. The EcoInvent database.
Now arriving at Heatherdoe.
The EcoInvent database is based on this cutoff approach, where we include the benefit of recycling. We say material that is made from recycling doesn't use virgin materials. It accounts for the burdens of doing the recycling. So the impact of the recycled material is simply that maybe you need to collect and reprocess the material, and then you get your recycled product. But what it does is at the end, when you send material to be recycled again, you basically end the life cycle there. You don't count any offsetting of virgin materials. You don't count the impacts of actually doing the recycling. So this works. We're only counting the benefit once, but it does tend to prioritize products made from recycled content rather than making something from maybe virgin content that can be recycled at its end of life. The second boundary, often referred to as the recycling credit, or the 0-100, and so you'll get this 0, 100, 100, 0. It's really referring to whether it's the credit for recycling is located at the beginning of life or at the end of life. So the recycled credit, we include the recycling process at the end of life, the efforts to collect and reprocess and grind up and wash and clean materials back into a usable product, which leaves the system to become something else useful, made from recycled material. And we give this whole product system, whatever it was, that was cleverly made in a circular economy with a system of collection and a system of recycling, a market that actually operates, and we give it a credit for displacing virgin material in the marketplace. Some form of virgin material, whatever it is that this recycled material is able to displace when it's utilised in a competitive market with primary products. Now, there is a gap here that I've left imbalanced. If you give, anyone who's an accountant will know that if you give credits, that somewhere in a system there is a debit to balance that. And so the debit in this system actually sits at this beginning of life. So if this initial material is not made from virgin material, is actually made from recycled content, it has to carry a virgin debit. So because the end of life, and imagine the previous system over to the left-hand side, the previous system has already taken a credit for displacing virgin material, the consequent debit for that displacement goes on to the next product that uses it. So the product made from recycled material carries a loan, essentially, that the previous life cycle took, where it said, we've already taken a credit for displacing virgin material. So the product that uses this resin has to model itself is effectively using virgin material because we've already taken the credit. So one credit up, and so they basically, you pass on your virgin material, you pass on your secondary material, but you don't give them the environmental kudos for having done it. You give that to the previous product here or the previous product over here. And this is the bit that really messes with people's heads, that when you can make something from recycled material, but you actually have to account it as having been made from virgin material. And people feel that it's extremely unfair, and that's sort of, you know, that doesn't work, and why do we have to do that, and why can't we just count it all? If you count it all, then you essentially double count. If you think that it should be, you should get the credit, then you need to go to this cutoff 100 process, where the burden is only given for using recycled content. And it's the sort of the physical reality of, you know, putting a boundary somewhere where it's a little bit natural. Here, there's no loaning and returning of, you know, debits and credits. It's just something which happens. So the cutoff 100 is very appealing for, you know, what you might call the common sense. Makes common sense because here you collect some material and you make something. However, it disincentivizes any product from prioritizing recycling at end of life. So if you have design options here where you can make this material either more recyclable by virtue of changing the additives, setting up a collection or some sort of stewardship system, but no one's ever going to give you credit for, in at least in an LCA sense, for making it more recyclable, because all the credit only goes to things made from recycled content. So that's the center of the dilemma, and we faced this 18 years ago, I think, when we first started put PK onto the market and faced the question of how we actually explained and what choices we made. Now, the resolution of this tension, there are a few different ways in which it's been done. If you look to the LCA literature, if you look to an attributional, what they refer to as attributional or a sort of retrospective model, the cutoff looks really common sense. It's like you attribute what happens to the processes. It's what you physically see happening is that people collect something and they make something a recycled material, and then that gets recycled and just gets sent off. And so in terms of the organizational boundary, this cutoff looks very, very sensible. If you want to look at what's the benefit of making changing from one system to another, we often then will look to consequential modeling approaches where we say, if we make something that's more recyclable, what's the net benefit of that? If we make something or don't bother recycling, what's the impacts of that? And so that's referred to as consequential modeling. In consequential modeling, there are the differentiator really is on the strength of the recycling market. So if we go back to this picture here, one of the real questions is that when we create recycled content, we collect for recycling, what is the dynamics of this material getting back into the market and actually displacing virgin material? If you are in a very strong recycling market where all material that is collected that's of reasonable quality will find a home, a market, and that the recycled market and the virgin market maybe are very, very similar. Maybe they're the same market, particularly with the metals. They tend to be, you know, very similar prices in the market. Then you're in a strong recycling market, and when in strong recycling markets, you need less incentives for people to reuse recycled content. It makes sense. Recycled content is cheaper. It's more. It's when it's available, you will use it. In that case, they will go to the end of life recycling credit, the 0-100. In a weak recycling market, it makes more sense to provide the benefit to products made from recycled content, because you need to collecting more material of something that currently isn't well recycled just adds to the stockpile, adds to the problem. If you are making new products out of recycled materials that are difficult to recycle, where the markets are relatively weak, then you are typically going to add to the amount of recycling by creating new products in that recycled product range. So making something out of, highlighting you're going to make something out of recycled aluminium doesn't really make sense, because aluminium is always going to be recycled. But making something out of soft plastics is very valuable, because we have significant quantities of soft plastics and we really struggle to get that market activated. While at the end of life, if you collect more soft plastics, you say, oh, it's okay, we've made it out of soft plastic, but we've got a new collection system at all the supermarkets, we're going to collect it all, and then we'll go and try and find out what to do with it. And so there the incentive to say, oh yes, and you've offset a whole lot of virgin material. Well, you haven't until you've really established how that material is going to be that you have other product systems for that material to go into. So that's how consequential modelling deals with these things. We then have what the European product environmental footprint took this idea and being the clever political pragmatists they are, they sort of said, yes, the strong and weak recycling market thing is a really good argument, but it's very on-off. Like, it's one thing to go and say, okay, if you're in a strong recycling market, we just don't care whether you use recycled content at all. That's like undermined a lot of activities for promoting people to use recycled content, particularly say something like the paper industry, where you've got, we often prioritize using secondary content, even though it's a strong recycling market. So they've switched to this sort of 80-20 rule, where 80% of the benefit in a strong market goes to the end of life, but 20% of the benefit is given to in the recycled cut-off approach, where they allow this overall magical recycling credit to be distributed a little bit for using secondary material, but mostly to make sure that you get that material back into the economy that you are recycled at the end of life to go off into new products. Because on the flip side, for weak recycling markets, they reward products made from recycled content. 80% of the benefit goes there, but 20% of the benefit goes to virgin material offsets at the end of life. And then for products that are fluctuating or a little bit uncertain, they've used this 50-50 rule, where basically they split the benefits 50-50 at the beginning and the end of life. For those undertaking LCA using tools like SemiPro and Gabi and things, this is a little bit of a nightmare. This is a lot of modelling and quite a intricate formula to apply. Nevertheless, it can be done. Thankfully in PIQET, we actually put all of this logic in 18 years ago, and it continues to be in there, where we've had as a default this 50-50 rule, which was put in before the PEF, and a lot of these concepts were really well documented. And today we now allow you to either stick with the 50-50, you can produce your own customized allocations between these different recycling rates, or you can select the PEF defaults, where it will use what the PEF recommends as these 80-20, 20-80 rules for different materials. So before I go on to the talk about the how circularity intersects with all this, are there any questions on or comments on that? No? Okay, cool. Hopefully that is clear. Oh, here is the this product environmental footprint thing is encapsulated in a formula called the circularity formula. A lot of people really dislike it. I actually think it's quite politically quite clever. So the formula, without getting too hooked up, this A factor is this magic 80%, 20%, 50% number, which gets integrated throughout the calculation to distribute the benefits of between beginning and end of life. So it's either 0.2, 0.5, or 0.8, representing the 20%, 80%, or 50% allocation between beginning of life and end of life. And I won't take you through the math. It's way too early in the day for us to look at this much math. But for example, something like steel has an A factor of 0.2. Plastics mostly sit in this 0.5, although you could argue that maybe clear PET and some plastics really should be more of a 0.2. And wood from pallets, something like and soft plastics and things like that would sit at a 0.8 A factor, so that 80% going to the benefit at the beginning of life. Okay, so that's within the PIQET tool. We're calculating, whenever we calculate recycled credits, they are effectively any recycling credit at the beginning of life or at the end of life, depending on how you look at it, are always divided by 50%. So often people will implement recycling and say, oh yes, we've switched from a virgin to a recycled product and expect the footprint to drop dramatically. It drops half as dramatically typically as people expect because of that 50-50 allocation. And so unless you want to go and customize that, and have a strong reason to do that, that's always a bit of a sort of caveat over the results that we get out of PIQET. But then we come to the circularity formula. And the circularity formula is sort of interesting that this whole 8-factor problem and things are a problem because of circularity. And very much as we go into industrial ecoecology, the modeling for LCA people gets harder and harder as we have more loops and more things made from the waste product of something into something else, which is a great problem to have because it means that we're starting to get an economy that is using itself in many different ways. The circularity measures, now there are a whole lot of different circularity measures, and we don't aim to go through a lot of the emerging measures like the material index and things. What we were after and what attracts us to the circularity index is something that sort of summarizes the recycling and reuse elements of our materials and products to give people an idea of the relative circularity of different product systems compared to each other. So it's based on the method developed by the Ellen MacArthur Foundation. It's implemented as a packaging metric, not as an environmental indicator. So we still have our environmental indicators, and this is really a process indicator, we might call it. And the value will range between 100% linear and 100% circular. The circularity metrics, they include the recycled content and recycling end of life actually in a 50-50 sort of balanced sort of way. So in a way it applies simply because it's averaging out the amount of movement of material of secondary materials at the beginning and end of life. So it effectively applies a 50-50 approach in balancing the benefit or the reward you're going to get for recycling on the input side and recycling on the output side. It also accounts for recycling efficiency. So if you're recycling something where you collect a kilogram of material, you reprocess it, and you only get 0.8 of a kilogram coming out, you've got a 20% recycling efficiency loss. That's a loss to the circular economy. And so that is added to both that recycling efficiency is applied as a loss at both the input sides and the output sides. It accounts for reuse, and the beautiful thing about reuse is reuse by definition happens at both the input side and the output side in the same way because you're reusing it. So every time you reuse something, it goes from the end of your system back to the into the beginning of your system, and so you don't need to resolve whether it's a beginning of life or end of life thing, which is sort of also interesting within the recycling context to say that if your recycled content and your recycling end of life are the same or similar, so you use a lot of recycled material and you make recycled products and you recycle, your products are recyclable end of life, you don't really need to worry about where this metric sits, because you're going to get similar credit from both ends of life. The circularity metrics also have the potential to account for sustainable, renewable content. So bio-based content that is sustainably produced. Because of the difficulty of deciding whether something is sustainably produced, we typically haven't had this as part of the calculation to date. We have, as people might realise, in the recent updates to PIQET 5, we've included the ability to track materials that are certified under the PEFC or FSC, Forest Stewardship Council, if materials are certified as sustainable, and we recognise that those certifications are great, but that doesn't necessarily mean they're fully sustainable, but they certainly stand out as being better sources of renewable material. Then we will allow that to be any materials certified as sustainable and based on renewable materials will be included in the circularity metrics, but we're still implementing that, I believe, into the calculation. The other thing which we currently don't include in the circularity formula is there is in the MCI a benefit for delivering more value for the same product. So if you have a product that delivers better than industry average value, so if you're producing something which is highly concentrated or lasts for longer, if you could demonstrate that, which is always a little bit tricky, we haven't included that in our metric because this tends not to be the strategies people are looking for, and the sort of proving it out is a little bit difficult. So that's not included. If you are producing products that deliver more functional unit per unit of mass or per unit of product, that can be accounted in PK in our functional unit multiplier, where you're able to specify that a product produces more benefit, but it won't affect the circularity, but it will affect all the environmental metrics. What does circularity not do? It doesn't look at the impacts of undertaking recycling or reuse. So it doesn't tell you that recycling or recycled content is better or worse than virgin materials or other approaches. Doesn't tell you how much better it is if it is better. Doesn't include, and sort of connected to that, doesn't include any impacts of transportation required for reuse and recycling, which may also, compromise the level of benefits from secondary content. And it doesn't reward low impact materials. So you can't just, with the exception of that bio-based credit, you may be sourcing a material that's made with a funky new technology where it's with large amounts of renewable energy. It doesn't deal with any of that. It's very much about the material flows at the beginning of life, really the reuse recycling equation. It's not trying to replace the carbon footprint, if you like. So here's where our packaging indicators sit as little speedos at the when you do your analysis. And I might just jump across to the tool and just show you where all this sits. Do I have the tool over here? Yes, I do. So hopefully you can now see PK. And I'm in a project that's been made by Gab. And just to demonstrate where some of the features are, in the settings of the project in PK, you can come down, and deep hidden in here are change default recycling credits. So if you are wanting to get a little fancy, you can come in here and move away from the PK default, which is the 50/50, go to the PEF method, or you can actually customize your own, if you don't like our implementation of the PEF method, or you have particular reason and justification for doing it, you can go to custom, where you can actually adjust the credit, and you don't have to choose the 80/20. You can choose any value. You could choose a 75/25 and apply that either to all materials or apply that to individual materials within the tool. And then just to show you, you go through the modeling, just to let you know where, when we have bio-based materials, and we haven't implemented it yet, but extend our session. Thank you very much. There is this certification here, FSC certification, or you can switch this to be PEFC. So this is this middle certification is the one that will apply to the circularity formula for bio-based materials. And we'll go down to the results, and we have here a case study just looking at 4 bottles, refillable polystyrene, high impact polystyrene bottle, a glass bottle, a paper bottle, and a polyethylene bottle. And when we generate the results, we get our normal environmental impact profile. So here's the impacts up here, looking currently at climate change. And then these are our metrics. And so we can see we have a percentage of recycled content in different products. The HB bottle has got about 17% recycled content. The glass bottle is about 50% recycled content. If we look at recycling to land, packaging to recycling, we see they've all got, and this is evaluated across the entire packaging system. So if there is secondary and tertiary packaging being modelled, and they have recycled content, this will average all those out on a weight basis. So here we can see we've got a little bit of recycling at end of life for different products. And then we have the material circularity index. And so for 3 of the products which don't have reuse, the index is very much just an average of the inputs recycling and the output recycling, less the recycling efficiency. So it will always be a little bit less. So you can see this one is sort of 50, this one is a bit over 50, and then this one comes down to basically 50 being the average of those 2. I think the purple HB bottle comes out there. For the polystyrene product, which has no recycled content and very little recycling, it comes out with a circularity of 0.66 because it's being reused a significant number of times. I'm not sure, maybe it's 5 or 6 times. Right, yeah. So this just shows how the metric includes the reuse and the recycling. Okay, might leave it there. Do we have any questions or comments or any other issues people wanted to discuss in the PK universe? Okay. No, well, thanks so much for making the effort to come in. I hope that is helpful just to explain how we deal with the recycling dilemma and then within the circularity metrics. And so, Gab, the next webinar will be?
So the next one, same time, or will be on Tuesday, the 8th of April. So yeah, same link. Sorry, there's a bit of noise in the background. Same link, and it'll be shifted back an hour for us, but the time should adjust accordingly if it depending on where you are. But yeah,
Is there a topic for that?
thank you. We'll also send out a recording if you wanted to look back on it as well.
Okay. Thanks, everyone. Have a great day. If it's still your day, have a great evening if you're in the evening.
Thank you.
Thank you, everyone.
Thank you.
Bye.
Bye.